Yeah, thanks, Sebastian, and for setting this up. And a huge shout out to this.labs as well for sponsoring, and Dustin for doing that awesome talk on GraphQL. My name is Westin, of course. I am going to be talking to you all about state management beyond context. But a little bit more than that, as I was writing the talk, I kind of realized I'm going to be talking about using React context in a performance critical app is how I'd amend that title almost. And I think we'll learn a lot about using context as a state management utility. And we'll also see a little bit about some of the pitfalls of using context as kind of your way to do state management. So a little bit about myself. I'm actually currently employed at PayPal. I'm a senior staff engineer on the web SDK. I've been at PayPal for about 6 months now, so I'm relatively new. If you've worked with our SDKs, have any complaints about them, I'd love to hear them. We're certainly invested in making it a much better experience for everyone. And if you're interested in working at PayPal or Braintree or any of the PayPal family companies, feel free to reach out. Other than that, I'm a longtime React user. Actually, back in the early days of this meetup, a colleague of mine presented on how we were using the Flux architecture back in the React 0.12 days. So it's kind of interesting to, he's long since moved to San Francisco, but it's kind of interesting to be able to present on a little bit about managing state here so many years later. And I've worked on React apps in small teams. This particular app we're going to talk about was a small team of just 2 of us. And I've also worked on React apps where there was 40 engineers in one application, which is kind of a crazy experience. So I've had a lot of experience around React. I've done a bunch of other things in the past too. I've done Elm in a past life, and I've done ReasonML in a past life. But generally speaking, I've done a lot of different things on the front end and on the back end as well. So hopefully I have some wisdom to share with you all, maybe. So I wanted to kind of tell a story about a front end app I had to build a little while back. Hooks had just came out, so it's like 16.8 for React, and this idea of I think it was around the time where that blog post came out, like Redux is dead. So there was a sentiment of like, let's not use Redux anymore. And I don't agree with that sentiment, but it was around at the time. And it certainly had me thinking in general, like, well, this is cool. What do hooks and context allow? And also around this time, luckily for me, I was moving from a consulting company over to a trading shop. And we were going to kind of have this carte blanche project to build some high frequency trading apps. And we wanted to build progressive web apps for them so you could use it on the go and do options trading and stocks tradings from your mobile device or your computer. We had a lot of grandiose visions there. So, we eventually wanted to scale it out to a lot of small and medium-sized apps. So sharing layers of state was important to us, right? So we thought, context is great. Hooks are great because they're simple. There's no other library needed. If we want to extract them to their own repo one day so that a few different apps can use them as a dependency, that's possible for us. And that was very enticing based on the direction we wanted to take some of the products we were interested in building. This is a really rough sketch of kind of what we were handed as an initial mock-up for one of these apps we were going to work on. And a lot of this presentation is going to be contrived. There's a couple different concerns around NDAs and just the app was a lot bigger than what we're showing here. So you might see some parts where you say, well, there's a clear fix here in an app of this size. But really, it was a little bit larger. So bear with me when you see some of the contrived examples. And this screenshot's an example of that. So I went to Excalibur and I just kind of built a shell and tried to hide some of the details. But essentially, on the left-hand side, we had these orders coming in. So think like nonstop streams of orders coming in from other folks who might be saying, I want to sell this particular stock or underlier, stock or option. And then you also have the orders you created, and you can see these notifications of like, here's how many people are bidding on these orders. And then alongside that, the numbers are constantly updating. And it's a user setting, but most users, we understood we're going to set it at like 200 milliseconds to 500 milliseconds. So we have these ticking data points of like, this is the last price of the PayPal stock ticker, updating every 200 milliseconds. We have a timer, we have notifications, polling, we have little graphs. Just on the order cards even, this is a much simplified example. And then in the center column here, I put what effectively would be us looking at a single order. And you can see at the top, we have a similar sort of paradigm with this stock ticker. We have some graphs, and this is all live updating. We have this table of numbers that would typically be about 20 rows by, or 20 columns by 50 rows. And every number in that table has a chance to update every 500 milliseconds or so. And then we had responses to the order. So if this was your order, you would see other people's responses coming in saying, I'm interested in your order, but I'm not going to pay what you asked for. I'm going to pay this. And we would try to intelligently suggest the best order. Like, hey, this particular order looks enticing. I think you want this one. And the long and short of it is there was just a lot. It was a relatively simple app in terms of not a lot of pages. Not a lot of states to transition from, but it had a lot of data, and this data was constantly updating, and that was kind of what we were nervous about, this constantly updating data. And so of course we reached for React context, new kid on the block, so to speak. This is the popular way to go, and we wanted to give it a go and see where we could land. To talk a little bit about the back end, which I think will be interesting to some, is that we did have a set of backend services that communicated to a gateway or a proxy layer, and that was powered through gRPC bidirectional streams. So all that really means is they were just sending a lot of messages back and forth on long-lived connections very fast. And that gateway talked to our web apps via WebSockets, of course. And that's kind of the nice, gRPC doesn't work out so great at that layer, so we went with WebSockets. And we essentially had this paradigm where you would subscribe to the data points you care about over a WebSocket. So you can kind of send these messages essentially and say, I'm interested in the PayPal stock. I'm interested in my orders. Maybe I'm interested in earnings for the Qs, QQQ, things like that. And we would send this all through the gateway. It would get to the proper service on the other end of the fence, and it would open up these long-lived streams, which is kind of an odd paradigm. We had these where we see the single stream from the gateway to the client, but it was kind of common based on some other things this company was working on, and it was kind of a paradigm that was working for them. So we have this one stream, and we're just getting hammered with messages through the WebSocket of everything we subscribe to. So that's kind of what we were dealing with on the back end, and now we're going to start on this front end project. And we're already dealing with messages just like blasting us in the face. So just kind of outlining this big fear that we set out on. And I made a little demo of the app here, and we'll be using this throughout the talk. It's, again, very contrived, very simplified, but we can kind of see, like, I put some orders over here. They're not going to change until you click this button. I have a very slimmed down version of an options table, and you can see that this one actually is just randomly throwing out numbers between 1 and 10, nothing too crazy, but just a random update point. And we kind of I put a watch list up here, and I think this will come into play in a moment. So it was great, everything worked. We used context, everybody was right, Redux was dead, we had no performance issues, no data complexity. Every browser worked great, and I actually, started planning my retirement somewhere warm, somewhere not in Chicago, somewhere where it doesn't rain, hopefully. But then we did some performance monitoring on it, and what we saw was not great. This is a screenshot of the flame chart from React DevTools. And it's meant to illustrate what happened when just order 2 in the list received a notification. So I went ahead and coded it up so that we can show some red borders on order notifications in all the re-renders. And when I click this button, it's going to pick a random order and simulate it getting a response. So we see Square got a response, but you see all that red flash on the screen. The middle section represents this first order of PayPal. But even when Square updates, everything's re-rendering, including the middle section. We see Square update again, and the middle section updates again. We can add something to the watch list, and one would expect just the watch list to change. But we see Tesla change. We see the order items change. This isn't great. We had a lot of performance issues. Data wasn't as complex as we hoped, and I did not get to stop working, unfortunately. So what I want to kind of dive in today is a little bit about React context. I'm going to have some flame charts about re-renders and dev tools. I'm going to talk a little bit about using Memo, a feature of the React library. And I'm going to talk about what we did to deal with the frequently updating state problem. So essentially context values that frequently update. And we did use those context values as a form of state in this case. So just diving straight in here, we have React context. So what is it? How do I use it? What is it good at? What is it not good at? That's what I'm hoping to cover here. So straight from React, context provides a way to pass data through the component tree without having to pass props down manually at every level. Notice no mention of sort of state management here. It really sounds more like dependency injection at this point. I have a piece of data and I can shove it somewhere else whenever I want to. That's kind of what I hear. And this is essentially how it works, right? We have this context provider, this React component, and we wrap our whatever portion of our React tree that we care about in that provider. We give that provider a value, and anywhere in the tree, a component can say, I want this value now. And the parent components, these components in the middle of the tree, they don't care. They don't have to know that this value is passed down. There is no passing prop from component to component to component. The prop drilling scenario, so to speak. We can just throw a value where we want to throw a value. And that's enticing. That's a pretty cool concept. A little bit about setting up context, not as much boilerplate as using something like Redux. You know, we essentially import, create context, use context, and then we want to use something for state. So we're gonna, in this example, we use state from React, because React does, well, context doesn't provide us tools for dealing with state. React does also provide us useState and useReducer, which are tools for dealing with state. So that's great. We can really kind of leverage those, and their end value can go in context. So here, this is more or less what's in React documentation, which is phenomenal. But I wanted to show it really quick. You know, we can set up this initial state object, which is just a counter. We can quickly create a context with a default value. And then we can create that wrapper component, the provider. And inside there, we'll see we set up our state value. We set that as the value of the context provider. And then later in our application, we can just use our hooks to get at that value. So, and one thing that's always great to do when using context is if context is null, it's always nice to provide a clean error message to your user to say, hey, you might have forgotten the provider that you need to wrap your component tree with to use this particular context hook. And reducers aren't too much different. You know, really the difference you see is when you push those values into context, you're using useReducer instead of useState. So now you, instead of state and a state setter, you get state and a dispatcher. So it feels really similar. And you know, you get a lot of the same benefits you had with Redux. You don't necessarily have one global store per se in the boilerplate of action creation that Redux imposed, but you can still add everything in your app into this reducer if you want one store. But generally speaking, most people will split it out because you want to keep it more atomic and small. But you have a nice mechanism to deal with your data or with your state, and it feels quite nice. And I think that's where it really comes in, the idea of is Redux dead at the time? And I think for maybe simple apps, it could have been. You know, we have a lot less boilerplate. We have something built into our library that we can use. You know, it was a very pleasant experience to use this. I think as apps would grow really large, I could see where it would fall apart. And that's kind of we can go into the good and the bad of this. You know, context, as I've been saying, is built into React. There's no other dependency to pull in. That's great for bundle sizes. That's great for cognitive overhead. It's all coming from one spot. There's not as much boilerplate. You know, it's simple to use and set up, and it removed the prop drilling problem. You know, I'm not passing props through all these components that don't care about the prop. You know, they can, this property I care about can go straight to the component that cares about it. And that feels nice. Our component APIs can be a lot cleaner. But there's some baggage here as well. Context changes will trigger re-renders of the components that are retrieving the value. So that component that asks for the value from context, it's going to re-render when context changes. And that's to be expected, right? We want that component to re-render when context changes because the value it cared about might have changed. And context is great, you know, for storing these small sets of data. You know, you can imagine that maybe you want a more robust solution in a bigger team or with some requirements around organization. But for the most part, it's really great at storing these small pieces of state. I think large pieces are when it starts to feel not as great, or complex pieces. But you can kind of still architect around that because you're in control of how you use context. But then you also run into another thing that we haven't really touched on too much yet, is what I've heard referred to as provider hell. And I would imagine if you've been using React and in the ecosystem, you run into this situation where you're like, my style library might have a provider. I'm using, I don't know, React Query has a provider, or you know, you start stacking these providers, and then you have your own providers, and you see your root app just moving slowly further to the right in this scheme. Because it's very common to wrap at the top level, because a lot of these providers are going to provide something useful to your entire application, such as your theme provider. Every component's likely going to want to be able to get at that. So it's important to also kind of get some background about when React re-renders, because that's kind of what we noticed when we looked at this stock trading app, was that it was re-rendering a lot. So, and we know that's one of the cons to context. It can trigger re-renders fairly frequently. So we know that React will re-render on an internal state change. We know that React re-renders when props change, when parents re-render, when parent components re-render, and of course when context changes, because as we just saw on a slide before. And if you're familiar with React, this isn't too much different than how it's always operated. If you're new to React, it's important to take note of these and be cognizant of when your components are going to re-render. And React provides us a tool to deal with numbers 2 and 3, prop changes and parent changes. And that's this memo function that you can get at through the React library. And actually, memo, similar to context, has a pretty slim API. You can import it directly from React, and you can wrap a component. And essentially what you're saying is, I want to memoize this component, similar like a Lodash memoize, and many other libraries might provide them. But you're saying, if this component is handed props, just do a shallow equality operation to say, did these props actually change from what I got last time? If they didn't, I don't need to re-render. It's a way to bail out from rendering deeper into your component tree. So, and this will be very similar to should component update from back in the day. So we can actually fix one aspect of our app pretty quickly. And as we saw, these order list items are always re-rendering when any response from an order changes. So we can look at the data in context really quick, just to give you a picture of what it looks like. Essentially, how this contrived example is set up is you have a very flat structure, but then you have an array of responses. So when I press this button, a random order gets a response concatenated into this array. So thinking about that, if the SQ ticker gets a new response on this order, we don't need to re-render PayPal at all. But it's re-rendering because all of context, because something in context changes, so that triggered anyone asking for a value from context to look for a change, to re-render. You know, hey, you might have been affected, you should re-render. So when we go to our order list, we can kind of see that firsthand. We grabbed orders from our hook that gives us the value back from context. And then we pass it to a list. And we're kind of mapping over each order and saying for each order, go ahead and render a list item. And that list item is kind of where memoization can help, because we can come in here and we know that for the bulk of these orders, they're not changing. So this flat order structure is the same. But there is one where it does change. And that's the only one we want to render. So what we can do here is wrap this in memo. And what that provides for us is a way for the order list to bail out of rendering through shallow equality if that particular order didn't change. So now you'll notice, whoops, this has been happening a bit with the examples, but I end up just needing to refresh really quick. But what you'll notice is now we can see that the orders can change independently. They don't affect each other. And that's great. And that's because of this flat structure of the data. It's a great use case for memo at this point. So we kind of solved this one issue quite easily. So kind of coming back to the slides here, we can, if we were to do some flame charts, we can see when order 2 updates in this order list area here, we see only a re-render on order 2. We no longer see re-renders across all of them. So that's great. We solved our problems, right? We just got to wrap everything with memo. But that's not the case, because what's happening with memo on the order list item is we're memoizing the props passed into it. But if we look at the center column here, and I've been calling this component order details in the code, it subscribes to orders, and it does take some information from orders, but like something like watch list is also subscribing to a value from our context. And watch list is subscribing to, if we go to our use orders hook, we can see that our state also has a little bit more to it. It also has, I don't know why it's stuck highlighted. It also has a watch list in it. And we're getting at watch list through that same context value. So we're saying, hey, I want watch list, but orders are changing, and watch list has nothing to do with that. And we're still re-rendering details about that one specific order as well. So we're a little bit better off, but we're still kind of in a bind here. So what can we do about that center area? We know that when context changes, everything listening re-renders, but we want more granular control. We want to say, I only care about this one part of my context, and that's not built into context. So why did it not work? Well, as I just said, context is always going to re-render if you're grabbing a value from it. It doesn't matter what value you grab. Something about that context object change. Maybe it's an array, maybe it's an object. If it's doing a by memory comparison here. So unless it's a primitive value, anything grabbing at it's going to change if you changed anything in it. So that's where this library React track comes into play. And this is kind of what we ended up doing on this app we were building. We wanted to continue to use React context, but we wanted to look for a way to be more intelligent about monitoring how context changes. So what React track promises was essentially this nebulous idea of state usage tracking via proxies. And it mentions it's going to optimize for re-renders. It's not framework specific, so you can use it with context. I'm sorry, you can use it with useState, useReducer, React Redux, Westin, any way you're handling managing your data. You can use React track as long as you're within the React ecosystem, because it does have some bindings there. But it's pretty cool idea here. For us using just context, useState, and useReducer, this was going to work great. The code for it isn't too difficult either, and I think the docs do a really good job of explaining it. But if we think about a very standard useReducer, We see we have our initial state object, nothing too fancy. We have a standard reducer, so React track still doesn't come into play. And then all we really have to do is sort of make this wrap our either useReducer or useState call in React in a function. So it becomes kind of this factory. And we pass that to this create container thing from React tracked. And that's going to give us back a provider, a tracked, a use track state hook to get at what's inside of state, and a use update hook to send your dispatch messages back to that reducer. It does give them back to you in an object that's named. So here we see some aliasing to names that are more convenient for us in the app. You probably don't want to call every provider just provider and every hook use track state because you'll run into collisions. So we kind of just alias those over to an orders provider, a use orders, and a use orders dispatch. I meant to remove that, sorry. So I actually went to the code and I made another code sandbox here so I can provide two different ones. And I did a couple updates to kind of make working with context more friendly. And the biggest one here is using React tracked. So I came to my, so this is the hook that I've been calling use orders, but it's really most of the state for the application. And I pulled in this create container concept from React tracked, and I went ahead and exported it. And it's named no different than it was before. I still have an orders provider, use orders. And I used to combine use orders and use dispatch, but now I have them separated, and that's OK. Small difference, but effectively, I only wrote a handful of lines of code here, and I pulled in one dependency that's not too large. And we can see that if we go back to the previous model here, I can show you how the reducer looks pretty much identical, right? So we still have watch, add to watch list, remove to watch list, update order. Most of these lines of code are entirely unchanged. It's just what we exported changed a little bit. It got wrapped in this library React tracked. So let's see what happens though when we wrap it. So when I respond to an order, it used to be that everything would re-render in the center area and just the order I cared about re-rendered. But now we see if I re-render the square order, that's all that re-rendered. So when square got a single response on it, the app was now smart enough to say, well, nobody's really listening to anything else on that particular object. So that's all that needs to re-render. Why would I re-render the montage table for PayPal, the options table for PayPal? When I change my watch list, the watch list re-renders, which is expected, but the order details section doesn't re-render. And this is pretty awesome. If we hit this enough, we'll eventually hit a point where when we're going to hit PayPal, and maybe I should have hard-coded in a way to directly hit PayPal. It's currently a map.random. See, there you go. I hit PayPal at some point there, and we see that, yeah, the center console area did re-render. It got this order responses area to show one of these order responses. And that's what we wanted, right? Because PayPal did truly change. So that's great. This magic sauce kind of worked for us. So we're feeling really good, but there was this magic sauce in the equation here. And when we look at a flame chart, if an order updates this order 2, same concept. If order 2 updates, only order 2 re-renders, which means only that one item in the order list will re-render. So we're going to kind of dive in really briefly about how did this work? How did this happen? What did React track do for us? So it did mention it was using proxies, and I think that's a big topic in and of itself. But I did want to talk a little bit about it and link to a good spot to read about it. So really what a proxy is and it's a newer browser feature, so sorry if you're stuck with IE 11 support. You are not able to use this, unfortunately. But most of the newer browsers do support this. It's not, it's just older browsers that have the issue. So generally speaking, especially as folks are deprecating IE 11, this is going to be available to more and more teams because of that browser support changing and IE 11 being deprecated by Microsoft. But what a proxy does is it essentially sits in front of an object, right? You define this proxy and you give it an object and you say, I want to intercept anyone trying to get a value from the object, set a value from the object. I kind of think about it like our gateway and our API, like it grabs all the traffic to this object and says, I want to do something when you reach out to this object. I want to monitor what's happening here. And this is a great example here. I really like this, that in their code, they call this, it's called a handler, this interception, it's dictionary of what you're going to do on interceptions. And one of them is the get accessor. So that's just accessing a property off of an object. So we can intercept that and say, hey, you asked for order.responses, and we know, and we can do something about that. And this is really fruitful for us, right? Because that's kind of what we wanted. We wanted to know what properties you were reading in the component. We wanted to say, hey, we're giving you context. We're giving you, context is changing, but can you tell us what you accessed last time you rendered? Like, did you care about all of the orders? Did you care about the wish list? Or did the last time you render, you only cared about, the PayPal order? And you can think about putting a proxy in front of the value you put in context and saying, I can track what each handler looked at each component looked at last time it rendered. And when the next time it renders, I can give it the same object it got last time unless something it accessed changed, because I have that information now. I have a registry of what you're accessing off of the object. And that's basically the magic of this library called Proxy Compare, also by the same person who wrote React Tract. Proxy Compare is kind of this lower level idea inside of React Tract, and React Tract is kind of the bindings to make it easier to use in React. Proxy Compare is very low level, but essentially what Proxy Compare does is automates this idea of you have an object and you have a next object, and you're going to merge those together, similar to like your useReducer case. You have a state and a next state, and you want to merge those together, but you also want to know what properties were accessed on the previous state before you do that merge, so that you can determine whether you want to merge every property and whether you want to mark a property as needed for mark a property as having changed in that update. So I made a small example of using Proxy Compare. And generally speaking, you wouldn't be using this directly with React Tract, but it's kind of interesting to know the underpinnings and how it worked. So I made a small state object with the status of pending and a nested object here called stock with the last price. And I wanted to kind of showcase how this magic works because it can be a little confusing. What Create Proxy is doing is it's taking an object you want to track, and it can be an array as well, and it can be nested. It can be an array of objects. It's very smart about what you give it. And then it takes a weak map. And the weak map is essentially to store the data that's accessed, right? The weak map is going to store like, hey, you asked for state.status. So I know that's a tracked field now. It's a field that you care about. And if it changes, you need to know if it changes. And it does that in a weak map. And a weak map is essentially just for better garbage collection and cleanup, but it's a pretty interesting and cool concept if you have time to look it up in your free time, but essentially just view it as a way to store essentially like a dictionary of changes. And you can look up what was accessed and what changed about it. And it's just kind of the bookkeeping to Proxy Compare to be able to do its magic. And here we just access proxy state.status, but because the proxy can intercept that get, proxy state.get, it knows that status is now tracked. It's a tracked field. So Proxy Compare gives an isChange function to say, given my original state or my current iteration of my state and a proposed next merge into it, did it change, quote unquote? And by change, it means, did it change in a way I care about? So one thing that's interesting here is we have a state object with status pending, and I'm passing in a brand new status pending object here. And it's smart enough to merge that intelligently and say, no, this didn't change. And then on the next line here, I'm saying, again, did this change? Did the state object change if I were to pass it pending, which is a no-op essentially? It's not changing anything. It might be a memory reference change if you're spreading a new object, but Proxy Compare is smart enough to deal with that too. but we changed the stock to the price of 9,000, which I hope PayPal gets to one day. And this is a real change, but it returned false. I said, did anything that I care about change? It said no. And the reason I did that is because it saw nothing looked at state, proxy state. You're typically dealing with the wrapper. Nothing looked at proxy state.stock, nor proxy state.stock.last price. So it didn't change as far as I'm concerned. And that's kind of what was happening in the magic of this application. When I changed something in the watch list, it knows that I really only accessed the watch list here. I didn't really care about anything else. Last render cycle, nothing else changed. And then we can see that if we now access proxy state.stock, we'll see that when we pass it the same status in a stock of 9,000, it can now say, something meaningful did change, something you cared about changed. And now it can notify, in our case, our component tree, hey, you can re-render now. Now, this is kind of the low-level details of how React Tracked works. React, there's a lot to React Tracked is a great library because it glosses over a lot of complexity while still being quite small. But it's a really cool concept. I think this concept can be applied to other frameworks, I'm sure, as well, or other libraries. But it was really cool. It was very powerful. And effectively for us, what that meant was in our application, we were able to continue using context without a hiccup. I don't know why Code Sandbox is like acting up a bit on both tabs for me. But we were able to continue using our app without a hiccup. And we had this side benefit as well, as like one of our original intents was to be able to share business logic, these plain old functions to interact with data that the app was getting. And because Proxy Compare works with plain objects as well, a lot of our business logic can just be vanilla JavaScript functions. We didn't have to do anything like finding a selector or a lens library like reselect. We didn't have to pull in like observables or anything like that. For our use case, we just said, hey, our objects are wrapped in something a little magic. And now they seemingly only update when they need to. More accurately put, they only notify us about updates when they need to. And this was quite powerful for us. It really helped us accelerate the idea of building this app with just context. Because like I said, it was a lot of ticking data. Context kept re-rendering for us. And React Track really unlocked the ability for us to continue using context, but do it in a performant way. And this is, I like my slides to kind of be visible offline as well if someone weren't in the talk. So this slide is something we kind of covered in Code Sandbox. And that's pretty much what happened. I didn't get to retire still. Turns out no one wants to pay me millions and millions of dollars to develop any single app. So until that day happens, I guess I keep working. But we did have a successful product and a few others, a small suite of products. And with that, that was my experience using context for the first time a few years ago. That was my experience dealing with the performance of context and how I found a solution. So any comments, questions, concerns, any hate for the PayPal SDK you should save for a DM though. And let me actually pull up chat really quick. I don't use Zoom a ton, so I'm going to have to kind of click around to see how to get it up. Ah, there it is. Cool. Yeah, so I got chat up. If anyone, oh, well, you can see my screen as well. So if anyone has any questions, feel free to toss them out there. That's a good question. How much state is too much for context? Thanks for asking. It's really, in my mind, it's really going to depend on what you're doing in your application. I think context is really best suited for a single domain. So I wouldn't want to store all of the data for my application in one giant context per se, because at that point, it just becomes a maintainability thing. So, using React Tract, like, great, we have something performant, right? Like, so maybe performance isn't always going to be the issue. Sometimes the issue is going to be, can my team understand the code here? And context is very simple. So if you're using useReducer, which I imagine most folks are for state and context, I try to slice it up by domain and say, like, maybe this slices orders, this slices watch list, this slices user settings, and kind of keep it tied to a single domain. And within that domain, in terms of the size of that object, I think it kind of goes down to keeping it understandable and maintainable for your team. So a big context object, if you're not using something like React Tract, yes, it'll trigger re-renders when anything changes. But it's more just about something that's easy for your team to use as well, because you can pull some levers to get performance improved. So hopefully that answers your question. If not, feel free to let me know. Cool.
Yeah, I don't think there are any more questions, but thanks, Westin. Really appreciate your talk. It was really cool. I'm actually using context heavily right now, so I could actually see that whole, or what do you call it, but like context nested. I have about like 5 contexts, so.
Oh, yeah, and I did want to briefly show, I guess there's a nugget in here that I forgot to mention, but I did. Speaking of that, you can essentially, instead of nesting providers using compose, composition is a great technique. And then you end up having just one component and it's just wrapped in a list of providers. So check out the code sandbox. I think that's a cool little trick, but it's not really worth a lot of discussion, I don't think, because it's just something you can do with plain JavaScript already.
Sweet.
Yeah, to echo that, thanks. This is really interesting stuff.
Oh, thank you. Thank you.